Hello and welcome to ATxSG. I'm Ben Wodecki and I'm proud to be joined by Professor Haoyong Yu from the National University of Singapore. Professor Yu, thank you for coming.
Thank you for having this chance to talk to you.
It's an absolute pleasure. We're talking about one of my favorite topics, and that's exoskeletons. I came by your booth earlier and was thoroughly impressed by the technology that you're showcasing. Talk to us a bit about what you've got on offer today.
What we are doing is trying to tackle the grand challenge of aging population. So when you have aging population, you want your workers to work longer, stay healthier for much longer time. And one of the factors that make workers retire early is the back pain. So we are developing technologies that prevent workers get back injury during their daily life in their factories, like in logistics, in construction, car manufacturing, and all sorts of activities that they are doing. So the device that we are developing is to transfer their load to other part of the body to prevent their back from get injured.
Okay, so yeah, we're talking about the inception of this technology. What kind of inspired you to kind of develop this?
So globally, we are facing the challenge of aging population. So we want to ensure that our workers can work longer in a healthier manner. So we want to protect them when they are young, doing their work in the factories, especially in the factories that automation are still not there, like airport, luggage handling, car manufacturing, and the logistic warehouses. So the devices that we are developing is trying to reduce the potential of back injury, shoulder injury, and neck injury. So with our device, we would like to see our workers work as normal, but they will not get all these muscle injuries or back injuries in the long run.
Mm-hmm. So we're going to cut to some footage of some demonstrations at some point in a second, but I want to hear from you, what can your technology do? How does it work?
So the device that we're going to see is a portable device that is about 5 kilograms. So when the workers wear this device, they can do the lifting of about 25 to 50 kilograms with much reduced load on their back muscle. So basically, we want to achieve like 40% of reduction of their stress on their back. So the device will not hinder or will not affect their work and will not reduce their productivity. But it's also not our aim to increase their productivity with the device. The device is aimed to protect them from injury.
Mm-hmm. So a lot of the early developed exoskeleton models going back 10 years had a lot of multi kind of locking arms and things like that. This one's focused solely on the back.
Yeah.
And the thing that excites me about it is, like you said, the lack of belt, right? It's purely from chest and knees. Talk us a bit about that.
So we want to have device that can fit in the human body without hindering their movement during their work. That's one objective. The second objective, of course, we want to have a targeted application so that the device is at a minimum cost and also be able to be adopted in the workplace. Otherwise, it's too expensive. It's very difficult for industry to adopt.
And the other thing that's exciting about this technology is you're also using it in rehab, right? Talk to us a little bit about that.
For rehab, we basically use the same type of technology with portable devices to help people regain their walking skill. So basically, for patients suffer from stroke, usually they will have deficiencies in their gait, like job foot, hyperextension in their knee or their hip joints. So we want to encourage patients to start walking again as early as possible. So we need to provide assistance. So we also developed a portable device so that patients can put on the device and the device can sense and detect how they are moving and provide the necessary assistance so that they can walk in a safe manner and increase the intensity of training so that they can recover faster.
Well, you've made some really exciting pieces of technology here. I was impressed by it, and I hope those of you are at home. But Professor Yu, what can we expect from your team over the next 12 months? Because it's a long road ahead developing this. What can we expect from the horizon?
So for the industry application exoskeletons, we are working with chemical factories. We are trying to demo, have field tests to workers so that we can improve our product. Of course, we are also looking for investors to start up the company so that we can roll out the product and benefit our workers as soon as possible. For the rehabilitation exoskeleton, we need to work with our hospitals first to try on our patients and improve those technology. And we're also looking for investors so that we can commercialize our rehabilitation exoskeletons to benefit our patients.
Well, we'll hope to hear more from you in the next 12 months. But until then, thank you for your time.
Thank you. So you want to have a look at the device?
That'd be great. Let's go for it.
Yeah.
So we're joined by Ding, and he's showcasing the work that Professor Yu has been making. Talk us through.
So this is the device that is to protect the workers from back injury.
Mm-hmm.
So during the daily working, let's suppose the worker need to lift up stuff from the ground, so you can bend and then show. So the device will transfer the load to the leg part, bypassing the back muscles. Mm-hmm. So it will prevent the back from get injured.
Nice.
Yeah. So the device will not affect his movement. So he can do this, all sorts of movement. While even if he's bending, he's carrying stuff, he still can be freely moving.
That's really cool. And before we went on air, Ding did a short run for us as well. I won't ask you to do that now. And it can work as well. There we go. Yeah. So he's easily able to move with this, and it's so cool from a commercial perspective. You know, I worked in supermarkets lifting boxes, and I could easily, you know, it would improve my posture. Professor, is there any other features? Because it's got Velcro applications here. Could you apply things like video cameras or anything?
So this device actually now is very easy to put on and to take off. And we have sensors actually tracking the movement, tracking his workload during the day. And we can analyze like how much his workload is on his body and how he's performing. So a lot of data analytics is actually built inside.
Okay, and then can a user then take that data and use it in an application?
Yes.
Wonderful. That's really great. Now, Ding, it's comfy as well. You're looking like you're enjoying it. Yes. How often is kind of the lift load? So you're wearing it, and there's no belt here as well, like we talked about. Yeah, which is really good. And they can wear like high-vis vests over it, and that's really good. No, is there anything else that you wanted to showcase here that you can show off for us? I mean,
so. Of course, the one of the critical factors for this device to be accepted is that it needs to be able to be put on and take off by himself very fast. So you can show me how do you take it off?
Okay. Yeah, when I take off, I will use this one.
Just release the straps, and then you just take off the vest.
Take off.
Yeah.
Simple as that.
Yes, as simple as that.
Very simple.
And they could be stored away in like a locker, something like that, and then used for the next day.
Yes, as your tool.
That's wonderful. Professor, you've got some really good work on your hands. What can we expect from you guys next year? How are you working to develop this further? Obviously, you talked about the investors.
We're going to improve the color. Just now, our president actually mentioned that we need to improve the color, and we are going to improve the ergonomics, improve the belts, and some part of it. And we're ready for manufacturing and sell to our workers.
Good. Well, we hope to see more of it in the near future. Thank you.
Thank you.
Thank you, Ding, and thank you, Professor.
Thank you very much.
Thank you.